Lesson 4 is about converting exponential equations to log form or log equations to exponential form. So in 4.1, we're going to start with an equation in exponential form and convert it to a log, and then 4.2 will be the other way around. So starting up at the top, changing an exponential equation into its logarithmic form requires you to log both sides of the equation. So logging both sides of the equation is just kind of like applying an operation to each side so you don't change the value, similar to like adding something to both sides or subtracting something from both sides of the equation. As long as you're applying that operation to both sides of the equation, you're not actually changing the value of the equation, you're just kind of rewriting it. So example 1, change each equation into log form. 1a is 3 to the 4th power equals 81. So I'm just going to rewrite it down here so I have a little bit more space, but 3 to the 4th power equals 81. And then what I need to do is kind of like cancel out the exponential to get it in log form. So I have to get rid of that like 3 to the 4th power, or at least rework it. So in order to cancel it out, I would have to apply a log because a log is the inverse of an exponential. Before I can do that, I have to decide my base. The base is going to be the same as the base of the exponential, which is 3 in this case. So that means I have to log with a base of 3 both sides. So I'll do log with a little 3 base next to the like 3 to the 4th power. And then whatever I do to one side, I have to do to the other side of the equation. So I'm going to log base 3, 81. And then now the log with the base of 3 and the exponential with the base of 3 cancel each other out. And you would just be left with the exponent from the exponential. So just the 4 would be left over. And then that's equal to log base 3 of 81. And then now the equation is in log form, so we're done there. So what we need to do to cancel out an exponential is use a log. Once we do that, you're going to be left with just the exponent part of the exponential left over. The like log and the exponential itself, the base, will cancel each other out. So altogether we have 4 equals log base 3 of 81. And then for b, it's 7 times 5 to the m equals n. So it's another exponential equation that we need to convert into log form. Before we can convert it into log form, we want the exponential to be isolated, meaning there's like nothing kind of being done to it. In this case, we have a 7 that's being multiplied by it right here. So in order to get rid of that 7 that's being multiplied, I would divide both sides by 7. So the 7 divided by 7, that would cancel out. And then I would be left with just 5 to the m power equals n over 7. And then now I have my exponential isolated, so I'm ready to switch it into log form. In order to do that, I have to figure out my base first. So since the base of the exponential is 5, that's going to match the base of my log. They should always match each other because that's the only way that they're like true inverses, is if their bases are the same. So we'll do log base 5 of 5 to the m. And then also, sorry I keep moving this over on you guys, but we're going to log base 5 over here of n over 7. So I'm going to put the n over 7 in parentheses. Usually when you have kind of like multiple parts, you want to include the parentheses just so it's clear that you're taking the log of the whole thing. And then the log with the base of 5 and the exponential with the base of 5, those cancel each other out. So we're left with just the exponent from the exponential, which is m. And then that's equal to log base 5 of n over 7. So just to run through it one more time, we had to log with base of 5 both sides because the exponential had a base of 5. Doing that isolated the exponent from the exponential, the m, and then that was equal to log base 5 of n over 7. And then for c, so x raised to the y equals z. I wanted to throw this one in there because it has like only variables and you'll kind of see them throughout. If you look at the like extra workbook problems, you may see it on the checkpoint. And it works the same way, it just we don't have any numbers. So I'm going to rewrite it down here, but it's x to the y equals z. So if I want to switch it into log form, first I have to determine my base, which is going to be the base of the exponential, which is x. So I'm going to log base x both sides. So we'll do log with a base of x on the left side, and we also have to do it to the right side over here, log base x. So the log with the base of x cancels out the exponential, and then it leaves me with just the exponent from the exponential, so y. And then over here equals log base x of z. So y equals log base x of z. So whenever you're given an equation in exponent or exponential form, you can apply a log to both sides of the equation, and that'll change it into log form. For 4.2, this is converting from log form to exponent or exponential form. So up at the top, changing a logarithmic equation into its exponential form requires you to something called exponentiate both sides of the equation, which is just like logging both sides, where it's an operation done to both sides, so it doesn't change the overall value. Exponentiate is going to be like kind of turn each side into a power over a chosen base. So example 1, change each equation into exponential form. So for a, log base 2 of 8 to the third, equals 3. So log base 2 of 8 equals 3. In order to change it into exponent form, I need to exponentiate both sides of the equation, and my base of my exponent has to match the base of my log, and the base of my log is 2. So I'm going to exponentiate both sides of the equation by 2, and that means that everything in the original line of the equation becomes an exponent over a base of 2. So that means you can technically just write it like this, but I'm also just going to write it in a fresh line so we can see it kind of all clean and nice. So it's going to become 2 as the base of my exponent, and then it's going to be raised to this entire thing. So log base 2 of 8, and then equals, and whatever I do to one side, I have to do to the other side of the equal sign, so I'll have to exponentiate that side as well. So that turns the other side, 3, into an exponent over 2. So everything in the original line became an exponent over a base of 2 to get that next line. And the reason that we do that is because exponentials and logs are inverses of each other, so they will cancel each other out. So now the exponential with the base of 2 and the log with the base of 2, those will cancel each other, and we'll just be left with what we're taking the log of, which is 8, and then equal to the 2 to the third on the other side. And whenever you're changing the form of the equation, you should still have something that's like a true statement, especially if you're not dealing with any variables. So we ended up with 8 equals 2 to the third power, which that's true because 2 to the third power means 2 times 2 times 2. 2 times 2 is 4, and then times the third 2 would be 8. So we're not just pulling numbers out of nowhere. These are true statements. We're just reordering kind of from log form to exponential. Okay, so 8 equals 2 to the third power for A, and then for B, it's y equals log base 3 of 8, x over 8. So I want to change it to exponential form. I'm going to have to exponentiate it. Before I can do that, I have to determine my base. It should match the base of the log, which is 3. So I'm going to exponentiate both sides of the equation by 3, so it'd be 3 raised to the y equals 3 raised to the log base 3 of x over 8. I'm going to rewrite it all together, so it'd be 3 raised to the y equals 3 raised to the log base 3 of x over 8, and I can't stress enough that whatever base you choose has to match the base from the problem, regardless of what form you're starting in, because you have to match the base of the exponential to the base of the log, or vice versa. So now the exponential with the base of 3 and the log with the base of 3 are inverse operations. So they cancel each other out, and we're left with just what we are taking the log of, which is x over 8. So we have 3 raised to the y equals x over 8. And then from there, we'll just want to isolate the x. So the x is currently being like divided by 8. So to cancel out that 8 that's in the denominator, we need to multiply both sides by 8. So multiply the 8 over here and then over here. And sometimes it feels like we should multiply like the 8 and the 3, but we can't because that 3 is being raised to a variable exponent. And with like order of operations, you would simplify exponents before multiplication. So since we can't simplify the exponent part, that means we cannot multiply the 8 and the 3 together. So we would just leave it as 8 times 3 to the y, and then equals, over here, the like multiplying by 8 and dividing by 8 cancels out, so I'm left with just x. So 8 times 3 to the y equals x is our exponential form. And then moving over to C, so m equals log base 3 of n plus 8. So again, it's in log form, so I'm going to want to exponentiate both sides of the equation. Before I do that, I need to decide on my base. So it has to match the base of the log, which is 3. So I would exponentiate both sides of the equation by 3. So it's going to be 3 raised to the m, and then on the other side it would be 3 raised to the log base 3 of n plus 8. And I'm not going to rewrite that line because I want us to get comfortable with just like kind of canceling it out from here. So everything in this original equation is now an exponent over a base of 3. So the exponential with the log base of 3, the exponential and the log with a base of 3, I kind of combine those together. The exponential and the log with a base of 3 are inverse operations, so they cancel each other out, and I would be left with just what I'm taking the log of. So it would be 3 to the m power equals the whole like 3 exponent and the log with a base of 3 cancel out, and I'm left with just n plus 8. And then I just want to get n by itself now, so I'm going to go ahead and subtract over the 8. So it would be 3 raised to the m minus 8 equals n as my exponential form. So 3 raised to the m minus 8 equals n.